Hello, welcome to our capstone project. This is Benjo Zhang.
This is Hao Chen.
I'm Bin Zhang. Here, we are very grateful to the support of our supervisor, Dr. Ali-Reza Mohammadi, and thanks to the help from our co-supervisor, Professor Menghe Miao from CSIRO, who provides the textile sensor for us using this project. Now let's come to the details for our project.
Recently, there were more concerns on hand rehabilitation, especially for stroke survivors. According to unofficial statistics, there are approximately 50 million chronic stroke survivors worldwide today, and 475,000 Australians are living with the effects of stroke. It is predicted that more than 56,000 strokes will be experienced by Australians this year. That is one stroke every 9 minutes. For the majority of these cases, loss of hand motor ability is observed, and whether partial or total. This can greatly inhibit the activities of daily living and considerably reduce one's quality of life. Our project makes a portable, assistive soft robotic glove prototype designed to monitor patients' hand motion and simulate in real time. It also supports remote hand rehabilitation diagnosis for individuals. There will be a broad application prospect in virtual reality fields as well. How would then explain the characteristics of the sensor we use?
The sensor we are using is a kind of textile sensor made of conductive fibers and stretchable yarns. Its important feature is that the resistance of the sensor changes when we stretch it on one direction. The resistance change curve is like a trapezoid. As the stretch length increases, the resistance increases first, then goes into a plateau and finally decreases to a certain value. So we could use the increasing zone as our working space to sense the hand motion by attaching it to the glove. This sensor has some advantages compared with conventional sensors. Firstly, it has good wearability and portability because it's very soft and virtually unnoticeable in clothing. Secondly, it's washable. You can even throw it into the washing machine like other clothes. More importantly, it's very suitable for patients. It's very flexible and light, so it could be easily worn by patients with different hand conditions.
According to the characteristics of this textile sensor, now I'd like to discuss the process and some details about how we made our glove in this project. We received these textile sensors and some 3D print finger models from our supervisor Ali-Reza, so we can start our project step by step. Well, the first step we did is project preparation. We did literature review about current sensors which can be used in this glove. And we also did some related investigations on existing sensor glove products in the market. After that, we specify our objectives in this project and the items we need to purchase online to complete this project. As we received all the things, we can start our structural design of the glove. We tested and calibrated our textile sensor with different sizes. According to the result of calibration and different layout of the sensors, we finalized the layout of the sensor on the glove to collect motion information of each joint. Well, the next step is signal processing. We used filtering algorithms to smooth the signal and remove the overshoot occurred. As mentioned before, all sensors on the glove should work in their working range to get valid voltage signal. We give different preload of each sensor when we fix them on the glove. Okay, after that, we are going to transmit process data to website for remote using. When we build a stable connection to the internet, process data from Arduino Megaboard will be sent to a specific IP address on the internet. Now we can open our browser and enter that IP address to check if the data is successfully sent. Fortunately, we get what we want in the browser. Once the data is sent, it can be downloaded for simulation in Unity to achieve a real-time simulation. Okay, now we have our first prototype of sensor glove. We can test all the functionalities of the glove and display it in Unity. A demonstration of hand motion tracking is available now. Okay, after that, I'd like to talk about some results of our project. As for the achievements, we built a textile sensor-based glove to track hand motion remotely. We successfully collect valid data and display the movement in Unity. Based on the feature of the sensor, we can realize a 10-degree accuracy from the hand motion to simulation. As for the further development, a software with UI can be developed in the smartphone for the patients to connect to the Wi-Fi easily and initialize the condition of the glove. Based on the application of this glove, further task-oriented programs like a grasp a ball at place can be developed in the app for rehabilitation exercise. Okay, that's all the things we did in our project. Thank you for watching.